Good morning. Assalamu alaikum warahmatullahi wabarakatuh. Today we will continue in section 2.1, but today we are going to learn how to sketch quadratic equation. If you remember last time, we learned how to solve quadratic equation either by factoring or by using formula. And today we will learn how to sketch quadratic equation. Don't forget that the general form of any quadratic equation will take the form ax squared plus bx plus c. F of x equals ax squared plus bx plus c. Today we'll sketch. We learned how to sketch before, but that was for sketching a line. In sketching line, if you remember, all what you need is just 2 points. Just 2 points, and that's it. Why do we need only 2 points? Because we are talking about line which is not changing its direction. It's moving from this point A to this point B, and that's it. No matter what you extend from right to left, then this line is not changing its direction. While for the quadratic equation, it's different. Here we are talking about line. As you see, this curve. This is curve, not line. So the curve is changing, always changing its direction, either for this shape or for this shape. All of them are changing its direction. So starting from this point, then this point, it's changing its direction. Now this is the direction. Now this is the tangent which shows the direction. This is the tangent which shows the direction. So it's always changing its direction, and the same thing can be said about this curve. So quadratic equation, the shape quadratic equation is not line. The graph it's not line, it is curve. And actually this is called parabola. This is called parabola. Now for quadratic equation, either we have this shape, shape number 1, or this shape, shape number 2. Or we can say this is shape number 1 or shape number 2. This is called parabola. So for a quadratic equation, we are talking about parabola. So how many points do we need? Well, if you want an exact graph, you need hundreds or even more. But finding or determining 100 points, it's too long and boring. It's not an effective way to sketch a quadratic equation. So what are we going to do? Well, we will just take a very close look at quadratic function or at the parabola. Well, this is the parabola or the shape of the quadratic equation. Takes this shape or the other shape. Well, in order to sketch or have, let me say, call it a rough sketch, not an exact sketch, we are looking forward, or we're going to look for the key points of any shape. I'm talking about this point, this point, this point, and this point. These are the key points which determine the main or general characteristics of any quadratic function. Well, if you remember this point, we studied this before. This is y-intercept. Y-intercept, it is the point where the curve or the line crosses or intersects with y-axis. That's why we call this y-intercept. And also, this is x-intercept, but wait a minute. We have here two x-intercepts, not just one, because the curve is crossing x-axis in 2 points. In point A here, in point A here, and in point B. So we have y-intercept, we have, this is y-intercept, two x-intercepts. In addition to this point is very important. This is called the inflection point, or in this case, this is minimum. Inflection point because this is the point where the function is reversing its behavior. Before this, it was moving down, 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 down until the function or the curve reached to this point, and then it's changing its behavior and moving up, 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 up. That's why we call this inflection point. So all what we need in order to sketch any quadratic function, we have to determine these points or these characteristics. Now, this is a smile function or happy function. Well, we need to determine y-intercept, x-intercepts, and the inflection point, and in this case, minimum. We said in quadratic equation, either it takes this shape or this shape. Well, this shape is called happy shape, and this is sad shape. This is U shape, and this is inverted U shape. So first we have to determine for the quadratic equation that we are requested to graph or to sketch, which shape it takes. Does it take U shape or a happy shape? Or it takes inverted U shape or sad shape? This is the first thing we have to determine. Number two, we have to determine y-intercept. This is y-intercept, the coordinate of y-intercept. Number three, x-intercepts, and as you see, we have two x-intercepts. Actually, in general, we have two x-intercepts, but it may take up to two. This means that two x-intercepts. In some special cases, you have just one x-intercept, and in some special cases, there are no x-intercepts. So we need first to determine if the shape is U shape, happy, or this is U shape or happy, or sad shape or inverted U shape. Okay. Now, let's summarize how to sketch. Again, this is the equation f of x equals ax squared plus bx plus c. First, step number one. We are talking about step number one. We will determine the basic shape. Is it U shape or inverted U shape? Well, it depends on the value of a. See here a? A, it is the coefficient of x squared. It is the parameter which determines the shape. Is it U shape or inverted U shape? Is it happy or sad? Now, if a, which is the coefficient of x squared, is positive or greater than 0, then we'll have U shape, like this. If a is less than 0, which means negative, then we will have inverted U shape or sad, like this. So if a is positive, we have this shape. If a is negative, we have this shape. Okay? So this is the first step. First step, we have to determine, is it up or down? Is it U, happy, or inverted U shape and sad? So this is step number one. Step number two, determine y-intercept. We said we have many points, many key points we have to take into account. So step number two, after we determine the shape is U or inverted U, up or down, happy or sad, we will go to y-intercept. Now, y-intercept, we can get y-intercept if you remember, if you substitute x equals to 0. When you substitute x equals to 0 at this occasion, then this term turns to 0. This term also turns to 0. So all what we have is y equals to c. That's why when you substitute x equals to 0, then y equals to c. So the coordinate of y-intercept is 0, c. So this is a rule. Whenever you want to find out what is y-intercept, it is just 0, c. C, it is the constant. You can find it at the occasion. This is c. So y-intercept, it is 0, c. Again, first step, we determine the shape. Is it up or down? By finding a. When a is greater than 0, then it is U shape, happy. If a is less than 0, this is inverted U shape, sad. Number two, step number two, which is determining y-intercept. In y-intercept, it is just 0c. This is the coordinate of y-intercept, where c, it is the constant, and you can take it from this occasion. Right, step number three. Now, we determined y-intercept. then it's the time to determine x-intercept. Now, x-intercept, you can get it when you substitute y equals to 0 or f of x equals to 0. This means that you will have the quadratic equation ax squared plus bx plus c equals to 0. Now, this is quadratic equation, and we learned how to solve a quadratic equation. It is either by factoring or by quadratic formula. Again, we may have two two x-intercepts. This means that we may have two x-intercepts, one x-intercept, and no x-intercepts. Okay, and we can solve this, if you remember, by using the formula or by factoring. We just remind you with the formula: x equals minus b plus or minus square root of b squared minus 2 minus 4ac, or delta, all divided by 2a. It's up to you. You want to solve it by quadratic formula, it's up to you. You solve it by factoring if you can, it's up to you. Okay, step number 4, we have to find out or determine the coordinate of the inflection point. Either the inflection point is maximum or minimum, then you have to find the coordinate of inflection point. The coordinate means x and y. Now, x can be found or calculated by applying x equals to, as you see from here, minus b over 2a. What is b and what is a? A, again, it is the coefficient of x squared. B, it is the coefficient of x. So as you see, all what you need, you find at the occasion, at the form of the occasion, or the occasion given. Okay, this is x. How can I get y? It is very simple. You will, after you find x, you will substitute at the value of x. So you have x and the value of the function f of x. Suppose that x equals to 3, then you have to go and find out f of 3. You substitute 3, x equals to 3. So these are the 4 steps that we need in order to sketch any quadratic equation. First of all, we have to determine the basic shape. Is it up or down? Number 2, we have to determine y-intercept, which is 0, c. Number 3, in order to find out x-intercepts, we need to solve this equation. And we can solve it either by factoring or by using quadratic formula. And then we have to find out the coordinate of the inflection point. And we can use this formula: x equals minus b over 2a and y equals to f of x, that we find from this equation or from this formula. Let's go to example. We have this example. Give a rough sketch of the graph of the following functions. Function f of x equals x squared minus 6x plus 5. F of x equals x squared minus 6x plus 5. This is the function. Now we'll start identifying a, b, and c. A equals to 1, b equals to minus 6, and c equals to 5. A, it is the coefficient of x squared, b, coefficient of x, and c, it is the constant. Now we'll start step number 1. If you remember, step number 1, we want to find the shape. Is it up or down? Now, since a is 1, which is greater than 0, then the shape is U shape or happy. So finally, it will have a graph like this. And since it is up, then the inflection point here, it is minimum, as you see. Inflection point is minimum. Okay? So again, since a is greater than 0, then it is U shape. And in U shape, the inflection point is minimum. So this is step number 1. We find that it is U shape, happy shape, up. Number 2, step number 2, we want to determine y-intercept. We said y-intercept, it is 0c, and since c equals to 5, then y-intercept, it is 0c and 0, 5. So we know that this is up, and we know that y-intercept is 0, 5. Step number 3, we want to determine x-intercepts. Now x-intercepts, again, ax squared, we substitute y equal to 0, so ax squared plus bx plus c equals to 0, or x squared minus 6x plus 5 equals to 0. This is the equation that we have. We have to solve this equation. Well, we can solve this equation by factoring. We can say that this is x minus 5 times x minus 1 equals to 0. And obviously, from this equation, either x minus 5 equals to 0, then x equals to 5, or x minus 1 equals to 0, then x equals to 1. Or you can use quadratic equation. This is a quadratic equation, minus b plus 1 minus square b square minus 4ac over 2a. So finally, we'll have two x-intercept. When x1 equals to 1, then the first x-intercept, it is 1, 0. You know that y-intercept is always 0. And when x2 equals to 5, then the second x-intercept is 5, 0. So we have two x-intercepts, 1, 0 and 5, 0. So just to remind you, we found that this function is up. We found that y-intercept is 0, 5, and x-intercept, we have two x-intercepts, the coordinate of x-intercept 1, 0 and 5, 0. Last step. In step number 4, we have to coordinate to find out the coordinate of the inflection point. Inflection point x equals minus b over 2a. So this is x. X equals minus, b is minus 6. Don't forget. So this is minus minus 6. Minus 6 divided by 2 multiplied by 1, which is the value of a. Then the value of x equals to 3. So finally, x coordinate to the minimum point equals to 3. In order to find y, we have to substitute x at this occasion, or you have to find f of 3. Now, f of 3 equals 3 square. This is 3 square plus minus 6 times 3 plus 5, which is, again, I'm going to write f of 3. This is 3 square minus 6 times 3, which is 18, plus 5. Now the answer, it will be minus 4, as you see. So x equals 3 and y equals minus 4. So the coordinate of that minimum point is 3 minus 4. Okay? Now I have all the information which enables me to sketch the graph of this quadratic equation. Let me summarize all the information that I get. I said that the function is U-shape, happy, because a is greater than 0. Y-intercept is 0, 5. X-intercepts are 1, 0 and 5, 0, and minimum point is 3 minus 4. These are the information that I get from the equation. Now I want to change this information into a graph to reflect or translate all this translation into a graph. Okay, this is a graph. This is a graph paper. First of all, I determine or identify or assign 0, 5. This is 0, 5, as you see. Then 1, 0. This is 1, 0. 5, 0. This is 5, 0. And 3 minus 4. This is the minimum, should be the minimum, and this is the minimum. Sorry, this is 3 minus 4. And I connect between all these. Let me just change it to green. Okay, you can just draw like this. And go down like this. You have to use your pencil in order to get a curve, not a straight line. So this is the sketch that you are going to have by using this approach. This is the curve x square minus 6x plus 5. Okay, this is x squared minus 6. Okay, what if we go to the computer or a graph calculator and feed him or ask him to sketch x squared minus 6x plus 5? What is the function or the graph of the function that will be given by the computer? Well, I went there, and this is x squared minus 6x plus 5. I get this graph or this sketch. I get this sketch. This sketch is graphed or sketched by computer. Okay? Now, let us compare between the sketch that we have and the sketch is given by the computer. This is the two sketches. See? Those are the two sketches. The green one is our sketch. This is our sketch, the green one. And the red one is the sketch given by the computer.